It was into this greenhouse world that our carbon atom had been released. Now it was one of the many CO2 molecules helping to keep the climate of the dinosaurs hotter than any other period in the planet's history. For perhaps 100 years, it swirled through the landscape, over oceans and deserts, mountains and lakes. Eventually, it drifted into a primeval Jurassic forest. It spent a season inside the leaf of a ginkgo tree, and another 50 years in the body of the dinosaur that ate it. It passed from plant eater to meat eater before being exhaled back into the atmosphere, once again as carbon dioxide. Our molecule drifts on and finally is swept out over the ancient Tethys Ocean. One day in the future, this warm equatorial seascape will become the oil-rich deserts of the Middle East. But now, the sea is rising, and so are the temperatures. Both the atmosphere and the oceans are loaded with CO2. Our molecule slips into the sea to become food for a phytoplankton cell. Trillions of these tiny plants swarm near the surface, all soaking up the sun and sucking in CO2. Inside this cell, our carbon dioxide molecule is transformed into an energy-rich sugar via the flash of a prehistoric sunbeam. As a means of capturing solar energy and storing it for later use, photosynthesis is brilliant. The cell divides, and then divides again. Sunlight and carbon dioxide are being harvested and squirreled away into organic cell walls and fatty carbohydrate molecules. The whole Tethys Ocean is blooming with phytoplankton. Jump forwards to our modern world. The individual algal cells in a phytoplankton bloom may be microscopic, but en masse, you can see them from space. Giant green swirls appear in places where plant food is concentrated by winds, currents or rivers, or trapped by restricted circulation. There are so many dead and dying plankton cells sinking down that their decay starts to use up the oxygen in the water below.
And if it removes all that oxygen, those deep waters will become anoxic. They're devoid of oxygen. And you'll start to screen out a lot of the organisms that just can't live.
As we drop into the increasingly stagnant green gloom, the leg of an oil platform becomes our only reference. From about 10 metres down, we enter what local fishermen have dubbed the dead zone. They find nothing alive down here to catch. A steady rain of microscopic bodies is now sinking uneaten towards the stagnant seafloor below.
And if there are no organisms there churning it up, moving it around, then essentially you have this sort of millimetre, layer by layer of accumulation of mud.
"300 metres below perhaps the most fertile region of the ocean today, the water is anoxic, totally devoid of oxygen. a steady rain of dead plankton cells has accumulated into a thick, quivering, uneaten, black organic ooze. And another step on the long road to an oil deposit is complete.
Many of the petroleum source rocks that we see in the geological record accumulated in these extremely unhealthy environments.
And so they did in the seas of the Jurassic Middle East. Even at the surface, there was little oxygen in the bath warm water. Below lay a dead zone that stretched at least as far as Western Europe. Our carbon atom, bound up inside its dead planktonic host, settled into the stagnant darkness, along with billions and trillions of other little hydrocarbon-rich corpses. The graveyard looks like today. Mountains of black rock.
Well, here at Kimmeridge Bay in Dorset, we have the so-called Kimmeridge Clay. And this is a black shale mudstone. So this is made up of the remains of plankton and clay, all these fine particles that have fallen through the water column and accumulated on the seafloor. If you look at these sediments in detail, you often find they're finely laminated. So there've been no animals churning them up, mixing them. The layers are just as they were when they were deposited during the late Jurassic.
These fine black shales have made southern England's Jurassic coast famous for the exquisite preservation of large animal fossils. But most people don't realise the shale extends deep under the country to the north and underpins the UK's bottom line as well.
Here at Kimmeridge, it's not mature, it's not been buried deeply enough to generate oil, but this, if you like, does the business in the North Sea. So this is very, very important for the whole economic well-being of the British Isles.
If you harboured any doubts that oil really does come from rock, you could always try this quick test. This is a bit of immature oil source rock, the Kimmeridge Clay, and this is a small flame. Put the two together, and in a few moments, the rock starts to splutter and burn. It's not a raging inferno, but that smell from the blue smoke is unmistakable. It's astonishing to think that what's burning here is fossilised Jurassic sunlight. But as a lump of rock, it's not much use for filling up your petrol tank. To drive out the oil, it needs to be cooked slowly in the moderate oven of the Earth's oil kitchen. And to enter the kitchen, the rock needs to be buried deep underground.
When it gets to a certain depth of burial, some thousands of feet below the surface, it's physically cooked by the pressures and the temperatures you get there, and the organic carbon cracks and goes from this original material to light sweet crude, as oil people tend to call it.
The temperature is critical. Bury the shale too far down, and it is overcooked into natural gas. Too shallow, and you end up with a half-baked greasy oil shale. Deep below Saudi Arabia, the conditions were just right, like a hot pot of tea for millions of years. Light, sweet crude containing our carbon atom began to flow like warm honey from the buried source rock. Of course, the Earth did not stay still while all this happened. The continents continued to break up and move. Mountain ranges rose and fell. Seas evaporated and returned. The face of the Earth changed completely. Around 15 million years ago, the Tethys Ocean finally closed up as Arabia collided ever so gently with Eurasia. The Tethys did not disappear entirely. Much of it simply folded and crumpled. Here in the magnificent desolation of Oman's Al-Hajar Mountains, the evidence of collision remains stark and dramatic. Welcome to the bottom of the ancient Tethys Ocean today. Baking hot, bone dry. Here in the Arabian Peninsula, there are kilometres and kilometres of these ancient marine sediments laid down right through the age of the dinosaurs. But there are a few places where you can walk on its surface. Here in the Hajar Mountains and in the Tuwaiq Mountains in Saudi Arabia. Pretty much everywhere else, it's buried deep beneath the desert sands. Three times during the reign of the dinosaurs, once in the Jurassic and twice later in the Cretaceous, thick black shales were laid down in the Middle East. So much that 2/3 of the world's oil comes from organic sediments buried here alone.
In Saudi Arabia and Kuwait and the 5 main Middle Eastern states, there were really singular conditions. You had a number of things that absolutely are required for giant oil fields. Really rich source rocks from which the carbon can be cooked at the right temperatures and pressures underground. Really excellent reservoir rocks where the oil can migrate through the microscopic pores and be trapped in these reservoirs. Really good so-called cap rocks. These are the impervious rocks over the reservoir rock that actually locks the oil in place.
Did you see the white color here?
And finally, really gentle structures, folded structures, anticlines, geologists call them, in which the oil could sit. Most people don't realize this. They think you can find oil anywhere. The vast majority of the planet is actually devoid of oil because these special conditions are not met.
Against these odds, the crude containing our carbon atom seeped ever upwards. It oozed slowly through the most porous and permeable rocks available, like ink in blotting paper. Eventually it could go no further and trickled into the limestone pore spaces of the largest oil reservoir on Earth. And there it stayed, trapped until humans came along. The sludgy remains of tiny, brainless plants waiting to hold dramatic sway on the future of the most intelligent life form the planet has ever seen.